Section 2.5 is on page 128, talks about the chain rule. This is the star of derivatives. This is something that you would apply every time you take a derivative, no exception. And this is the end of the actual mathematical work, busy work. After that, we're going to start really applying those, use mathematical and economics and see how this applies. This is what it says. It says if you take a derivative, if I want to take the derivative of y with respect to x, if y happen to be a function of u, then I'll take the derivative of y with respect to u. Chain rule times the derivative of u with respect to x. You notice I can cancel those two out and get dy dx every time I need to. Equivalently, I'll talk about this once we do few problems, and I'll come back to it and show you. That's a shortcut. So this is how it works. I have a function that I want to take a derivative of, and I can't. I'm looking at problem number 2 on page 135. I'd like to take a derivative of this. The idea is that I could multiply by this by itself 3 times. That's a lot of work, right? Imagine this was to the power of 30. Then the work becomes really intense. This is what you do. If you change this into 2 functions, if you think of the inside of a power function, the inside of a radical, the argument of a log, the exponent of an exponential, the denominator of a fraction, if you let that be, and even though the book writes it this way, I want to write it the other way. I want u to be right there, and y to be f of u. So, I'm going to switch those. Let me see. Give me a sec. And here we are. I'm going to let u equal the inside. U equal x squared minus 2x plus 3. Now think about it. If I take this out and put a u instead, wouldn't y equal, instead of this, wouldn't that be u to the 30th? And what's so special about that? I know how to take a derivative of this, and I know how to take a derivative of this. I just don't know how to take a derivative of the composition of those two. If I went on the bottom problem, if I let u equal the inside of the radical, if I let u equal 9 minus x squared, guess what? This y would equal the cube root of, and if I put u there, and there it is. And in case you're wondering how am I going to figure out this derivative, isn't that simply u to the 1/3? I know how to take a derivative of u to the 1/3, bring the power down, subtract 1 from the power. I know how to take a derivative of 9 minus x squared, and that's the trick. If I'm looking at this problem, I would let u equal the inside of a radical, the denominator of a fraction. So x squared minus 3. The deal is, I'm letting u be something I can take a derivative of. Then, wouldn't y equal 1 over the square root, and in place of that mess, it's just a u? And wouldn't you say this is u to the negative 1/2? And again, initially, I didn't know how to take a derivative of this. Now I could. This is very hard to do. I don't know how to take a derivative of that. Now I do, and with this as well. The idea is, I have y equal a function of x. I go on the side and I let u equal some part of x, and put a u there, whatever that is, and y become f of u. And now if you take the derivative of y with respect to x, we say now y depends on u, and by the chain rule, we continue on, by the chain rule, u, whatever this is, u depend on x. At any given time, I can cancel those and get dy dx out of it. Well, let's practice this and let's put it to use. And here's the next set of problems. I'm looking at, did I give you a page number? Yeah, page 135. If I look at number 8, again, I have an option. I'm going to make that 30 so you wouldn't think of multiplying this by itself 3 times. Observe how this works. If I let u equal the inside 3x squared minus 2, doesn't that make this y equal u to the 30th? So all what I do, I let u equal this. Now if I take dy dx, always dy dx, that's going to be dy. What does y depend on? Y depend on u now. Times, and automatically whatever this is, that's where the word chain will come from. And what does u depend on? X. Now, what's the derivative of this with respect to u? Bring the power down, subtract 1 from the power. There it is. And what is the derivative of u with respect to x? What's the derivative of that? Isn't that 6x? Get rid of u, and there, you've done it. So dy dx is going to be dy dx is going to be 30 times. Remember, initially there was no u. Replace u by what it equals, and there's the answer. I know I could multiply that. I'm choosing not to because I needed to see something when I'm done with these 3 problems. So I get to the next problem. I'm looking at the next problem, and the same thing. I know how to take a derivative of 4th root. I know how to take a derivative of 6x minus 5. But what I'm going to do, I'm going to let u equal the inside of that radical. That indicates that y is no longer a function of x. If you put u in there, isn't that 4 times u? Isn't that 1/4 power? And now when I say find dy dx, wouldn't you say y depend on u and u depend on x? So dy dx is, what's the derivative of this with respect to u? So the derivative of this with respect to u, 4 times, bring the power down, subtract 1 from the power, 1/4 minus 1, negative 3/4, times the derivative of this. Well, can I take a derivative of that? Yeah, what's that? That is simply 6. So altogether I have dy dx equaling u to the negative 3/4 times 6. And what was u again? Substitute u back in and everybody's happy. U was 6x plus 5. There it is. If I look at the last problem, the same deal happens. I'm looking at this and thinking, okay, well, there's a power function. I'm going to let u equal the inside of the power function. That means y must equal, if I put a u there, isn't that u to the negative 1? And now if I say find dy dx, wouldn't you say y now depend on u and u depend on x? Dy dx, wouldn't that be bring the power down, subtract 1 from the power, times the derivative of this function du dx? The derivative of that is 3x plus 4x, 3x squared plus 4x. And get rid of u, and there it is. And wasn't u x cubed plus 2x squared? Now I'd like you to glance at this. When I say step back, I don't mean take an actual step back. I mean think about this for a minute. Just for 1 minute. Look at what we're doing. If I want to jump from this to this straight, I could. And how is that? I look at a problem, and do you see the highlighted part? I don't see that. The outsidemost function, I'm looking at something raised to the 30th power. Do you see that it's like bringing the power down, leaving that as is, subtracting 1 from the power, times the derivative of the inside? That's what this is saying. If you could see the function embedded, when you take a derivative, you ignore that. You take a derivative of the outsidemost function. That is, something raised to a power, a radical, that's the outsidemost function, right? Later on we're going to know about sine, cosine, all of these things. And then times the derivative of the inside. That's the chain rule. So let's try that. Let's try that on these 3 problems again. Oh boy, okay, you know what? There's an easy way out. That one. That one. If I really want to go, and again, I'll keep on doing the long way until we get the hang of this, but eventually you're going to have to do that. You really don't have to. But it's just you're going to do this on every derivative. If I want to take a derivative, well, I ignore this part. Meaning, I only see something raised to the 3rd power. Well, don't you bring the power down? Subtract 1 from the power. Copy whatever that is, times the derivative of the inside. What's the derivative of 3x squared minus 2? And there it is. It was 30. Remember, it was 3. I made it 30 here. I left it as is. It's very simple once you get the hang of it. It takes enough practice for you to get the hang of it, and luckily I'm going to give you enough practice. So this is very quick once you get the hang of this. You look at this problem, you say, you know what, I'm going to rewrite this. This is actually 4 times 6x plus 5 to the 1/4 power. When I take a derivative, dy dx, the 4 I ignore. Bring the power down, subtract 1 from the power. So this part you ignore completely. You just take a derivative of this part. You bring the power down, subtract 1 from the power, times the derivative of the inside. What's the derivative of 6x minus 5? A 6. That simple. And here, you could say, look, ignore the inside of the radical, the power function. If you want to take dy dx, that is, again, the outsidemost function. Bring the power down, subtract 1 from the power. And this you just copy on, times the derivative of that, which is 3x squared plus 4x. And there it is. Very simple to get. Now let's practice that on these problems. Here's one. If I glance at this, do you see the inside most function is this? So when I take a derivative, I'm going to leave this alone. I'm going to leave the 2x cubed minus 6x alone. I'm going to take a derivative of something raised to a power. You bring the power down, subtract 4/3 minus 1 is 1/3, times the derivative of the inside. The derivative of the inside is 6x squared minus 6. Hopefully that's making sense. At any given time, you could write u equal and transform the problem. On the next problem, I'm going to change that slightly. This requires the quotient rule, right? Look how simple that becomes. And how does that work? G prime is in one line. The 3 I leave alone. Well, let's see. The outsidemost function is this part. The inside I leave alone. I'm not going to touch the inside. So it's kind of like getting a box within a box. You open the outsidemost box, and that's from a distance. When I said step back, you should see the power function first. Bring the power down, subtract 1 from the power, times the derivative of the inside, which is 14x plus 6. That's pretty much it. Now, if you have to write it back, you could write it back. You could say, well, let me undo what I did. This is negative 15 times 14x plus 6, and a negative power. Since I moved this up, I'll move it back down. And there it is. You could do that at any given time. I want to take the derivative of this. Well, this requires me to take the product rule. F prime would be derivative of the first, which is 3x squared, times the second, plus the first times, what's the derivative of this? Chain rule. Bring the power down, subtract 1 from the power, times the derivative of the inside, which is a 1. Now, on a test, this is all I want. When I say do not simplify, that's what I want. For the homework, you're going to say that is 3x squared times x minus 4 plus 2x cubed times x minus 4. And on the last problem, if I want to take a derivative of this, the insidemost function happened to be this mess. So the outside function is really this cubic function. If I want to take the derivative of y with respect to x, the first thing I will do is take care of the outsidemost function. Bring the power down, subtract 1 from the power. And I leave this alone. Times the derivative of this. And what do we know about that? Well, that's the quotient rule. Derivative of the top times the bottom minus the top times derivative of the denominator all over the denominator squared. And again, this is good enough. I really don't need you to clean that up for now. Just practice finding those derivatives. Now, I am limiting the homework. I should give you a lot more than this. I don't want you to do busy work. If you feel like you did this homework and you're still hazy about this, you should do more. But this is the bare minimum.